Most of us are aware of the fact that a global approach to quality improvement is a major emphasis of ASQ. Martha Gardner is an accomplished leader in global improvement to quality. She is the global quality leader for General Electric Global Research and has been since 2004. She leads the GE-wide design for Six Sigma, design for reliability, and design to value councils. She is currently focused on integrating new conceptual design methods and approaches using TRIZ into daily work at GE Global Research and improving analytics capabilities across GE Engineering through the GE Analytics Engineering Program. She is a fellow of the American Statistical Association and the American Society for Quality. She is serving as one of the 3 vice presidents of the American Statistical Association. So Martha.
Okay, fantastic. Well, thank you so much for having me today. And I was told to, emphasize the global nature of the kinds of things that we do in GE, and really tell you about our quality approach within a research environment. And certainly a lot of times people are like, quality approach in a research environment, because we don't actually manufacture and deliver things out of that research environment. But yet we know that it's very important to have that upfront look at things and really do what I call quality by design. So making sure that we're thinking about the quality of the end product all the way back in the early research phases. So, of course, we have a long-standing history of innovation within GE. At our research headquarters in New York, we have Thomas Edison's desk that he used. So long history for us, and certainly, even to this day, a very motivational figure for people within our company. And if you look at our history, we were founded 1892, so well over 100 years ago. Around 150 billion in revenue. We have just over 300,000 employees, and that is worldwide. And I tell you, just over the 17 years that I've been with the company, dramatic shifts in how much of this resource is actually overseas versus here in the U.S. And we're the only company that was originally on the Dow Jones Index in 1896 that is still on it. So today, we're actually structured in different business units. And so I like to tell people, I sit at our research headquarters, which is considered part of corporate GE, but there's actually not that much corporate stuff within GE. I like to tell people GE sort of has a loose federal government, but is very much a states' rights company, okay? And with the states being our business units. And at our research center, we work very closely with all of these different business units that are out there. And so some of you may be familiar with some of these, like our aircraft engines and power and water, big gas turbines, healthcare. A lot of what we deal with is obviously big equipment, but also a lot of financial services as well for our big equipment as well as our capital business. So it's been very interesting over the years to look and see where, like for example, some of our top reliability folks have actually moved from engineering into services organizations over the years because they recognize the importance of that in our service contracts and modeling and that type of thing. So we're really what I consider market-focused R&D. Another thing, if you look around, like even a few decades ago, there were a lot of companies that had corporate research centers, but a lot of those companies don't have them anymore. So, we're very proud that we have this strong structure in place, but it's because we're so tied in with our different business units. So if you look across our research centers, we have about 2,000 or more, it's actually a little more than that, scientists, about 2/3 of which have PhDs. Now, this is in an overall population across GE of like 40,000 people that we consider like scientists, engineers, technologists, that type of thing. So we're a small percent of that, but we drive a lot of the front end of innovation type of stuff for the company. So this is a very, very interesting story, because for pretty much like 100 years, we had our Global Research Center it's the place I work in Niskayuna. We're actually the headquarters for Global Research, but that was it. And in fact, just yesterday, I was talking with our guy at the Research Center that manages all of our export control type of stuff and licenses, things like that. And I was telling him, wow, it's just so amazing just in the 17 years that I joined, how the demographics have changed across global research, and not just at our overseas locations and stuff, but even at our locations in the United States. And he said that, yes, when he joined 36 years ago, there were only 19 foreign nationals at the research headquarters. That was it. Okay, so, and I'm sure that many of you, see this exact type of thing in your corporations as well. Certainly we see it within university programs and things like that. We started our global story with building a research center in India. And basically, the people that are there, a lot of people typically thought of like IT outsourcing and stuff like that, but that's not what our research center was ever really about in Bangalore. It was really having, deep expertise in a lot of different technical areas, whether it's, materials, mechanical engineering, and all of this to really help serve local markets. So we started in Bangalore. I was already with the company when we did that. I remember going there when it was basically like a tent in a parking lot. And now there's 5,000 people at that site. And not all of them are research employees. That's another thing that I think has helped us really sustain our model, is about 10% of the employees there are research employees. The rest are in co-located business units. So they're right there on site, working with people who are working with the commercial folks, out with the customers, and dealing with that every day. And then we quickly went into China, have research center there, and then went into Europe. So really, from 2000 to 2009, there was a lot of activity in this area. And then since 2010, even more activity. We just moved into our new facility down in Rio in Brazil. So now we have research site there. Also have co-located business unit folks there as well. We have a software center of excellence out in San Ramon, California. Now has 1,000 people at that. So we have quite expanded the footprint. I mean, when I joined the company 17 years ago, we were it, okay, in upstate New York, and now it's all over the place. So in my role as the global quality leader, I have like lead master black belts, if you will, at almost all of these sites. Okay, so that's part of what I have to do. When we have a new site that's coming up, then I have to look at, okay, what is that site going to need, and how are we going to get those resources in place to sort of, to really build it up. Fortunately, we're usually not building up from scratch, which is one of the advantages of GE. So, for example, when we started our software center in San Ramon, we had people that went from our software solutions group and our power and water business, very strong quality folks that actually moved out there and sort of served as the foundation. Now we basically have all the agile coaches out there are doing their black belts and stuff like that, mentoring all the green belts. And so that one has actually come up pretty rapidly. And now we have like our new site in Oklahoma City that we're just now building. We'll have to do something like that there, although it will be smaller. We now have our first black belts down in Rio. So this is the kind of thing, it's always ongoing process, right? So it's not anything that says, oh, well, now we're all quality people, so now we're all set. But that's not how it works, because there's always new employees coming in, there's new sites we're building. So, from my perspective, the sustainability aspect of this is like key, especially when you're talking about looking at a global perspective and how you run quality for your company. Like I say, I look at it really from like a research and engineering viewpoint. But it's amazing, everybody wants to do the best thing for their company, and the engagement has really been impressive. So this right here is just some of the big innovations over the years, and what's really cool about the ones from this last sort of 10 to 15 year time period is it's not just U.S. people that did this. Okay, this is people from all of our research centers working on different pieces of it and working together to make the new technology happen, make the new products get out the door for our business unit. So that's something that I'm very proud of. Like, for example, when I look at like our battery program, incredible number of black belts that have worked on that at the research center. And one of the best ones that we had was, it was actually a joint report out between one of the task leaders in Bangalore and one of the task leaders in New York, and they had worked on sort of two different pieces of the whole CTQ flow down, if you call it, but worked on the two different pieces, reported out together, and then how their stuff flowed up together to deliver the value. Okay, so a lot of that joint work is what we really try to push, and honestly, for quality people, I think it comes very natural for us to do this and have that collaboration regardless of where people sit or what they may do. So some of the things that we do as a research center, obviously we deliver core technology for the new product introductions for our business. So we have people, once again, all over the world that have been very involved in like the next generation aircraft engines that are coming out, many black belts and master black belts that have certified based on different work for these programs as well. Same thing for our next gen MRI systems as well. And then I already mentioned, with some of the new technology, the advanced battery work that we're doing, and now, of course, that is like in full-scale production. They have their own quality teams as well, but we're still at the research center working on even like next generation types of things for that program, and continue to have people that work on their black belt certifications and their tree certifications and all that on these next generation programs. We also spend about 10 to 15% of our budget every year on what we call advanced technologies. And actually, I sit, as the global quality leader, I sit within the advanced technology group. So I think that may be a little unusual as well. And I've been in that group for about 7 years now. So I work directly with people that lead the different advanced technology programs. So these are programs where we're really looking at like, okay, what might things be like 10 to 15 years down the road? And what technologies do we need to have in place? And to be honest, we may not even be sure, in some cases, exactly what business will end up owning the technology. That's part of what we have to figure out, is where should the first applications be, where should the first home be. But once again, all of these programs are led by people with very strong quality focus. Many of them are certified black belts or master black belts. And we do that in the research center. We do those certifications, sort of enroll certifications, like they do it as part of their research work. So that is a little different from how a lot of places do it, but for us it's worked out very well, because I could not go to, say, one of my best biologists and say, okay, I want you to go do this quality job for 2 years, and then 2 years later they try to say go back into their research work, and if they haven't kept up with what's going on, then they are considered to be behind. Whereas if I say, hey, do this as part of your research work, I get a lot more buy-in. And I still run a waiting list every year for the black belt program across our global sites. So we have many people, like I said, all over the world that work on the advanced technologies. And then certainly one of the things that we do is really spread the technologies across across GE. And I consider that one of the biggest things that we can do as a research center is help identify these opportunities. And this is certainly something I've been focusing even more on as we have technologies where it's really not so clear exactly which business may need to launch, but making sure that the different businesses understand what we're doing and figure out what are the best opportunities to move forward first. And then I mentioned already our new software center that we have built out in San Ramon, California. And this has really gone along with our focus on what we're calling the industrial internet, really making this a core part of GE. And in a lot of cases, I mean, we had the data, we had the capability, but really having like the big picture framework around it, as far as I'm concerned, that's really been the big advantage of having this out there, is really trying to make sure, our machines are connected with each other, that we understand what's going on. I mean, it really goes into understanding our services, our repairs, I mean, all this kind of stuff. So we've hired a lot of people. We've also had a lot of experts within our different business units, and even from the different research sites that have moved there to San Ramon to be there in the hub of all of that activity. And I really think that this has been a big shift for us over the last few years, is the focus in this area as well. And one of the things that I got asked to do a couple of years ago was, certainly I'm sure that many of you have seen this. I mean, the statistics that talk about, the need for, like, say, data scientists and stuff like that, and there's not enough graduates. I mean, there's been many articles that's been hashed over and over. Basically, what we have said is, obviously we're still going to hire these experts and stuff like that, but there's no way we're going to be able to hire all the ones that we would need to hire. So what we want to do is improve the capabilities of our existing engineering workforce. So that's why in 2013 I started an analytics engineer program within GE. It is completely voluntary type of program, and it's completely word of mouth, and I have hundreds of people that are doing the program to really try to bring these kinds of skill sets into their toolbox. So for most of these people, they have, like, say, a Greenbelt level, type of background, because many of them are still required to do the Greenbelt certification and stuff. This is really taking it to the next level, understanding kinds of things that are important for big data, what are some of the new programming paradigms, all this kind of stuff. But it's just been amazing to me. I mean, I thought, oh yeah, there'll be a handful of folks that'll be interested in this, and I was wrong. I mean, I've even found there are people working in places I didn't even know that we had stuff going on there, through this, and it's just amazing that they're all doing it together. So, I mean, talk about like it's a global education program, really, and just the engagement it's been very fulfilling for me to see that, but they're recognizing, I mean, this is a big deal, and they need to have that skill set going forward. So we certainly want to develop world-class talent, I mean, across GE, bring people together from all different fields of science and engineering, pull them together to solve the problems. I think that that's one of the big advantages that we have. And then we do a lot of partnering as well. So we partner with other companies on things. We'll have different kinds of joint ventures. We also partner with different universities out of the research center, and certainly government agencies as well. So, of course, all the partnering needs to make sense for us. In other words, something that it's going to push forward, that's going to help the company. But it's always cool to have that sort of other viewpoint, that come in. And certainly one of the things, at least for me as a quality leader, that it's provided is we may have, like, for example, we have joint research programs with Eli Lilly, and I've had the opportunity to do benchmarking with basically the guy that has my job for Eli Lilly Research. And that sort of sharing has helped our quality program as well. So even though that's not what the partnership is about, it gives us a framework and a structure to then have these other discussions as well. Now, in terms of our organization and process, and I know you guys, that's what you're really interested in, right, is process stuff. So, the way we're structured, like I mentioned, we have, our big business units. And then at the Research Center, we have someone we call a business program manager whose job it is to manage that relationship between the business unit and the Research Center. So that's part of how we help maintain that connectivity there. And then we have 5 what we call technology domains, and all of the researchers sit within one of those, well, almost all of them. There's a handful of us that are in advanced technology, but everybody else sits within one of these technology domains. So you see things like aerothermal mechanical systems, manufacturing materials, and so on and so forth. And then we have technology center leaders at each of our other locations as well. So we have someone who manages the site in China and in India and so on and so forth. And they all come together to discuss strategy, what are the things that we need to be thinking about, and then really try to represent, okay, what are the things that we need to do as a research center that are going to impact all these business units, and who should be engaged out of all these 40,000 people from across the company. So when we look at our research programs, one of the things that I implemented several years ago at our research center was the use of technology readiness levels. So a lot of times people would ask me, oh, what's the NPI process for the research center? New product introduction. I'm like, okay, yeah. We don't have one of those because we don't actually make anything, at the end. I mean, if we're working on a technology that's going to go into an NPI, we need to follow the business's NPI program because that's what's going to take us to the end gate. But we still need to understand how we're progressing across what we're doing. And it's also really a communication thing because, you know how researchers are. They get very excited about their results, right? So we would have some sort of report out, let's say a CEO of a business is there, and we've got the researcher who's very excited about their new chip and presenting it and this and this and that. And then the CEO says, oh, well, do you think we can get that into our machine next month? And then the research is like, deer in the headlights. And they're like, we were just happy it didn't blow up. Okay? So it's really trying to connect those two things together and really track, progress through our research program. So one of the things we implemented technology readiness levels. So that's sort of a part of our language now, our quality language that you'll hear people say, oh, well, what TRL is your project in? And somebody might say, oh, well, we've got this one part of it here that's still sort of TRL 3, but we've got this other part here that's TRL 4. So like I said, it's part of our language at this point. And we've also implemented manufacturing readiness levels as well. Obviously customized for our environment. Actually, all of this is somewhat customized for our environment, but looking at the different threads of things. So, okay, quality management system. When do you need to start thinking about the quality management system when you're going through the MRL process and things like this? So things that a typical researcher may not have thought about at the beginning, but now they have this to help them think about, okay, hey, if we're actually going to now take this and scale it up. And we certainly have spent a lot of time in terms of thinking about what we sort of called the valley of death, basically getting things from that sort of research environment and actually into a real manufacturing environment. So we have a pilot development facility now in Niskayuna. We also have a small site in Detroit where we have big space there, and those spaces are all about scale up. Okay, so how do we basically go through, like, say, TRL 6 and 7 and really demonstrate some of these things and get ready for business transition. Now, certainly one of the other things that's really come into more discussion lately is things around commercial readiness as well. Okay, so it all ends up tying together. But basically, how we look at this across any of our NPI processes, across our different businesses, the processes may be slightly differently, but they all have this similar sort of structure. As you go through concept into feasibility and development, And we look at Design for Six Sigma as sort of being an underpinning for all of this. So we don't have a separate DFSS process from NPI. In fact, most people that have been doing this a long time in GE are pretty much like, you know what, DFSS, it's really a tool set. So what we've done is a lot of work to make sure that that tool set is integrated appropriately into the different NPI processes across the businesses. And then certainly when we describe our TRLs to our new employees, we don't just give them the list. I mean, if you give them the list, that's sort of like, huh? But we also tell them, okay, if you're in TRL 2, this is what you're typically doing when you're in TRL 2. And if you look at those descriptions of what you're typically doing, there's a lot of DFSS type stuff that's baked into that process. So one thing that we do, so Gordon mentioned, I lead the Design for Six Sigma Council across GE. So basically that council owns things like the Book of Knowledge, certification requirements, all of that, making sure everyone's on board. We obviously do look at, okay, what are like the new design technologies that are coming out? What do we need to integrate into what we're doing? Because we recognize, you know what, design technology is like any other technology. It evolves also. So there's new things happening all the time. How do we take that? How do we pull it in and then build it into what our scientists and engineers are doing? And it's, for us, I mean, a lot of it is really about driving organic growth. Now, in terms of the research center, when we look at, I mean, you know, who helps us sort of drive this across the research center? It's our black belts and master black belts. So I mentioned before that they do these jobs just as part of their technology jobs, whether they're a biologist, mechanical engineer, even the statisticians. Some of them will do their black belts also. I did mine when I was in the statistics lab also. So that's why people will say, well, I'm not sure how this makes sense. You know, I'm designing algorithms. I'm like, oh yeah, let me show you my black belt project. You can do this. Okay, so anyhow, no matter what sort of field you're in, there's obviously some customization, but it's a similar sort of structure, the things that we need them to do, whether it's, you know, coaching, obviously they're bringing their technical expertise into what they're doing along with the quality skills, being a strategic integrator, and a lot of focus right now on systems thinking and systems engineering as well across GE. And then basically what we do is, that's sort of like the overall structure, but we have other opportunities to really go into more depth on some of the different areas. So like, for example, people that really get into like the trees methods, because guess what? They're sort of an earlier TRL type person. That's what they do. They do a lot of conceptual design, and they'll do that on one project, and then, you know what, they may go to another project and do a lot of conceptual design on that other project as well. So I have a lot of people that get very engaged in that type of program, and they move from being like a trees practitioner to a trees expert, help other teams. So we really try to customize things based on what people want to do. Now, then those people, like I said, depending on whether they're more upfront people or maybe say getting it through like the feasibility stage and stuff like that, if we look at, you know, along these processes here, if we talk about like say taking things from concept to feasibility, a lot of work goes on in this area, early marketing. We're using a lot of what from the lean startup principles. So some of you may have heard of the book by Eric Ries, Lean Startup. I mean, in GE we call it FastWorks, but a lot of focus on this right now. And what's been very exciting for me, a lot of our MBBs and BBs are the ones that are becoming coaches for this. And really what it's all about is understanding commercial risk. So there's in any program, there's technical risk and then there's commercial risk. And the lean startup principles can really help address some of the commercial risk. And we have a lot of that. I get pulled in a lot. I'll be honest, I'm more a technical risk type of person. That's what I do. I work with lots of teams across all of our research sites on looking at what they're doing, what are the technical risks, facilitating them through IP strategy, you know, this type of thing. And so what's happened is we started doing this. I would be working with a team, helping them on some sort of, say, process. It's like one team was in China. I'm helping them with their process, addressing the technical side of it, but at the end of the day, you know what? The business model isn't very clear. And we all know at the end of the day, we need to make money on this. So I told them, I said, you know what? You need to go talk to our marketing person. We have a marketing director within the research center, and I think that this would be a great FastWorks project, for that part of it, because there's the commercial risk. So some of you may have heard about that type of those type of concepts and stuff, and that's really where we're using them on the commercial risk aspect. And then certainly a lot of proof of concept, risk assessment. So we really look for our MBBs and BBs to really guide our teams a lot through this upfront sort of phase. So we look at, what's going on in the industry with our customers, obviously a lot of direct work with the customers and the competition. And then in terms of like our CTQ definition, one of the things that I've really tried to emphasize as a quality leader at a research center is that meeting performance requirements is necessary, but not a sufficient condition for project success. Okay, so we definitely need to meet the performance requirements. But what we really need to do is understand what the value statement is for the customer, what's driving the purchasing decision, and then really how can we minimize the overall life cycle complexity. So it's not just, when I see a project that's just all the CTQs are performance related, I start asking what's missing. Because need to ask those questions earlier rather than later. Now, in terms of the design focus, honestly, for a lot of quality people, DFSS people, this is the most, because this is where you're using a lot of the intense methods and stuff like that, really trying to understand variability. So that's what I tell our researchers. If in your research program you can understand the key drivers of variability in what you're doing, you're going to save someone a massive headache down the road when they're trying to figure it out. So we really focus a lot on solving problems, understanding variation here, and honestly, this is where a lot of our green belts are working, is they're working on tasks to answer some of these research questions in this area, really put the designs together, stuff like that. And when we think about where we're headed, it's really becoming more, like I tell you, over the last 15 years, a lot more simulation and modeling focused now than it used to be. Obviously, we still build things in a lab, don't get me wrong. We still build things and mix things, okay? But there's a lot more capability now in these areas than there used to be. And we're really trying to go from, just a purely, say, empirical type of approach to really get to modeling robust solutions and doing more in that type of design, so that we can ask, okay, how much risk is in the design? And we can do those comparisons, and we can do those before we spend a whole lot of money building stuff. Still a work in progress, but this is definitely direction that we're headed in. So when we look at our DFSS process, and especially, across the research center, we look at sort of the upfront part is really more like the MBB and BB focus, and then the green belts are really doing more like the design and optimize type of work. Now, this is a very sort of generic look at it, but it's usually how I explain things, to our new employees when they're like, now, I have to do a whole thing start to finish. I'm like, no. Okay, no, your black belt needs to do that, so. Now, one thing, Gordon also mentioned in the introduction, over the last probably 7 years, I've spent a lot of my effort on really thinking about how we come up with concepts for how we solve problems. So really conceptual design phase. And there are methods out there that can help. A lot of them are traditional quality methods, like say root cause analysis and stuff like this is really part of this toolkit. And we've always talked about trees within our DFSS curriculum, but it was very limited in terms of its breadth. We've expanded that a lot. And we do a lot of workshops now using these methods, and have done a lot to drive the culture. So some of you may be familiar with change acceleration process. This actually predates Six Sigma within GE. We're talking about going 25 years ago now. But do you know what? We still use the CAP process a lot. Anytime we have, something new that we're trying to get going, certainly I tell people, even with a new technology, you may have a new technology, we think it's great, it gets great performance or whatever, but you know what? At the end of the day, someone has to make it, someone has to sell it, and someone has to service it. And none of those people are going to be sitting within the research center. So we really use CAP every day because you're trying to get people to do things differently. So really going from, okay, what's the current state to what the future state should be, and then going through different methods to really get through this process. What's the vision, and do we have the commitment in place, and then how do we make it last? And so from a trees perspective, what we did here, first exposed a wide group of people to the principles and processes with immediate project application. So this is one thing that we did that I think is very different from what we did with Six Sigma, is when we do these workshops, like I was just running one Monday through Wednesday of this week. Very good that this conference was on Thursday and Friday. I was working with 3 teams, and they're actually working on their actual project while they're in the workshop. And at the end of 3 days, they have some ideas ready to go in the disclosure system. So that's been huge for us. And as we went over time, when we started doing this a few years ago, I really thought, if someone had said, what do you think this will look like in 5 years? I really thought that we would probably be doing a couple of workshops a year at our major research sites. That's what I thought we would be doing. I had no idea that we would be doing as many workshops, facilitated sessions. Between what I did this week and Thanksgiving, I have two more sets of dates where I'm working with specific teams on specific challenges that they have, but we'll be using these methods to help facilitate them through that. And so now, like I said, we have a whole trees practitioner, trees expert program. Of course, a lot of the people that do that program are my BBs and MBBs. A lot of them are. But guess what? Not all of them. Some of them are just green belts, but they really do a lot of that kind of work. So that's really what I've come to over the course of my quality career, is really trying to understand what is it that people enjoy doing, and then giving them the tools and the skills to help them do that even better. And it may not be what I think is the best thing overall or what, but if they're passionate about it and then you build up those skills, then they can influence a lot more people than I can by myself. And so this is how we have it structured, is we have people attend workshops in teams, and we have focused a lot on like our chief scientists and our principals, lab managers, key project leaders to drive the methods in their projects. Now what's been really cool, I've had a good number of people, when they've reported out on their DFSS Black Belt projects, they have extensive trees components within it. So we're not trying to treat it as something as separate. In fact, early on when we started doing this, I had one guy that came to me, he goes, so now that we're doing trees, does that mean we're not doing Six Sigma anymore? I looked at him, I said, do you still need to define your CTQs? Yes. Do you still need to know how well we can measure them? Yes. And when you have your concept, do you still need to do robust design? Yes. I said, so what do you think? We're still doing Six Sigma. There you go. Okay, so it's really adding to the toolkit here for how we look at this. And like I said, our impact of this has been very clear. Hundreds of new disclosures, designs with significant cost savings, simplification, improved performance. And like I said, not just with this, there's all sorts of different quality methods that are all coming together to help move this along. And then, of course, as we go into, from our development into scale up, a lot of application of lean methods. So there's some of you in here that are probably even like, lean masters and things like that. So I have a lean leader on staff at the research center. Once again, people are like, but wait, you're not manufacturing anything. Okay, yeah, but you know what? We do a lot of process development work. here, a lot of it. And these methods really help us in terms of streamlining things early before they get out and cause problems somewhere else. And so a lot of work around like looking at different value streams and what's the flow and the waste. We also have done a lot of lean work on our actual laboratories as well. So you can imagine, we started a new research center in Shanghai. We're building it up very fast, like literally as parts of the building are getting built, labs are being built in them and stuff. So it happened very fast. Now, and there were certain research programs we're working on at the time, but okay, you can imagine a few years down the road, some of those programs have changed a lot. People are doing different things. So we started doing projects where we're looking at, okay, how are our labs organized? Are they organized the best way? And you've seen the spaghetti diagrams, right? We started doing spaghetti diagrams of just how researchers, how much time they spent walking from like lab to lab. I mean, okay, let me tell you, they were definitely getting their exercise. Do not get me wrong. However, it's not the most efficient use, okay, of what they need to do. So it's always looking at, okay, what are the research programs that we are going on now? How are we utilizing the lab space? Do we need to move things around, reorganize things? And then certainly as we've looked at, we've had technology that we developed to the degree where now it's time to manufacture it, and now they have to put in, we're building like a whole new building for this, and you know what? Our lean leader at the research center is involved on that team on figuring out what's that manufacturing space going to look like based on what we've done with the technology back at the research center. So definitely big impact there as well. And then I've mentioned this is just sort of our basic quality roles that we have at the research center. We still require Green Belt certification for all of our exempt employees. Now that's not the norm. That's not the standard across all of GE right now. I mean, certainly, once again, each business gets to decide. Everybody has some sort of training that they do. And then most of our engineering organizations require the certification. But we have consistently required that over the years. And now, because of it, that's why I have about 200 black belts and master black belts running around all over the place. So anything that I need to get done, I have a huge number of resources that I can contact, and based on their interest can then help out. So we have the Green Belt program is the only thing that's required. Our black belt and master black belt program is completely voluntary. It's done in role. We run wait lists every year. And if we look at our management team, about 75% are certified MBBs or BBs. Almost all of our chief scientists are. Over half of our principal scientists. So, and like I said, it's voluntary. Now, what I do tell people is, within GE, I mean, if you're going to go up for a job against somebody and everything's the same and one person has that black belt and the other person doesn't, the black belt's probably going to get the job. Okay, so it definitely has a meaning within GE. But for us, it's not considered a requirement to get promoted, but it's very interesting. People see the value in doing it and that it helps them. And because it helps them like that, then that helps them in their technical work. Then they get promoted. And just the last thing that I wanted to mention, we do have a strong continuing education program. In other words, we don't try to shove everything into our green belt or black belt program. We recognize, hey, there's some people that do more simulation type work. So you know what? We send them to a class on probabilistic design for that type of thing. If we have people that are actually making things in a lab, then they go to the experimental design class. And then we have the different specialized certifications. I mentioned the trees ones. We now have an analytics engineer. We also have reliability practitioner and expert programs. That's actually across the company. And to get the reliability expert certification within GE, you do have to have an external credential. So that could be, say, a master's degree in reliability engineering or an ASQ CRE certification will count for that as well. We do a lot of facilitation on different methods, risk assessments, QFDs, all the kinds of stuff that I'm sure many of you are doing every day. And obviously, I could talk about a lot more stuff, but I think that I will stop there. So, are there any questions? Yes.
One of the big challenges. One of the major challenges that an organization such as your own has is creating solutions looking for a problem. You know, historically, particularly in research divisions, that's what we've always encountered. How do you manage the knowledge that you create, which doesn't immediately have a home, and you will have that knowledge, and it may have value in the future, but that whole knowledge management issue, I'd be interested to hear how you deal with that.
Okay, so there's multiple ways that we do deal with it. One of the main ways within our research center, first of all, I should say, one of the big things that I always drive as a quality leader, it's what I leave the green belts with at the end, is documentation. I tell them that at our research center, I think actually the most important thing that they deliver is the documentation, so that we have that record, and it's not just up here. So we have an internal report system within GE Research. It actually goes back decades, many decades, and it's amazing the things that you can pull up in there. So people are very strongly encouraged to write up their results and put them in there, but it's not just a stick, there's a carrot also, okay? Because every year we have our big technical awards type stuff, and you get recognized for like every 25 publications that you have in the system, and this doesn't have to be things that were just submitted to journals. Internal reports count. So certainly for the black belts, they're required to put their documentation in the system, and many project leaders. I mean, it's just sort of a natural part of the process. I mean, when you come to work there, this is part of what you're expected to do. So it really is amazing, I mean, the stuff you can find. I mean, and I've been at the center long enough to see, like, a new technology that came out for, like, a certain business. The roots of that technology were actually done back in the 70s when there was, like, a big oil crisis, but then that sort of, eased up, right? So we went down other paths. Now we come back again to it. They're actually able to go back to all that work from the 1970s. Guess where it's sitting? That system. Anyhow, pull it all out and then use that as like foundational type of stuff. So that's one way. Obviously, we do a lot of patenting as well. And then certainly within our business units, we also have, and a lot of them have like formal design practices. So for example, I serve on the probabilistic design board. I'm one of the leaders of that for our aviation business. Even though I sit at the research center, I'm on the leadership team for that. And we have a design practice around doing probabilistic design for aircraft engine design. And it gets updated and reviewed and stuff like that. So we also have these formal design practices, work instructions, things like that as well.
Yeah, hello. Some of the tools you mentioned are efficiency and commercializability focused, not quality focused. Mm-hmm. How do you separate that? How do you stay focused on quality?
Okay, I guess at the research center, I don't really try to separate it, to be honest. I mean, what we need to, at the end of the day, be focused on is what have we, say, turned over to the business that now has become a product. Okay, because that's when it's making money for the company. So depending on what some people, what a team may have a problem with, then we'll make recommendations. Hey, you know what? We need to think about this tool over here. And honestly, it may be more some sort of commercial type tool. But they may have something. I usually think of it more commercial risk or technical risk, like I mentioned before. If it's more like technical type of things, then that's more of the traditional quality type of tools. But we really teach it as like a comprehensive toolkit to some degree, and then what the mentors do is really help people figure out what's really needed for what they're doing.
Hi, to whom do you report, and how does he or she measure the effectiveness and efficiency of your organization?
Okay, so a couple of things here. So I report to the Vice President of Advanced Technology, Michael Idlecheck, and he is an officer of GE. So, and I've reported to him for 7 years. Now, in terms of organization, though, under that, just to be clear, I do not have an organization. I'm actually on the technical career path. I'm a chief scientist. I mean, this is by my choice. I've always considered myself a technical person. So I tell everybody, I don't really have a staff. I have a couple of hundred volunteers, okay, running around. So, and I understand that that's very different from how it is most places, but it works for me, and it seems to work. It seems to work for our center. So basically, one of the things we really look at is, okay, how are we moving technology through the process? And we know that these methods, number one, they help us weed things that aren't going to work. They help us weed things out early. And then they also help us be successful in the transition. So we really look at it, it's really from a broader research perspective. You know, what are we delivering to the business? Have we delivered what we said we were going to do? And if things didn't work out, have we gone on and moved on to something else faster? And then, of course, you know, we look at like IP and things like that as well. But my metrics are really like the overall research center metrics from that perspective. All right.
I actually have two questions. You can answer either one or both of them or neither.
Okay.
The first one is, if a business unit has a product that they would like to be developed for them, do they ask you and you develop it, or do you look at the feasibility and marketability and all of that and then decide whether to do it, or what is the relationship? And my other question is, if the engineer who invented the digital camera in 1975 had been a General Electric employee, what would have happened to that idea?
Okay, well, for the second question, I'll be honest, I don't know. What would have happened to that? But I tell you, one thing I can say is, we have some people at the research center that I've seen who were really passionate about a certain idea. And even though it wasn't the right timing for the company, they sort of kept at it and had had management that sort of let them keep at it on the side. And then it was amazing how 10 years later, now all of a sudden this is a big thing. And you know what? We have something, we're not starting from scratch because we had this person with the vision and sort of kept at it on the side. All right, so we do see that. And one thing that I think is really cool about where I work is, really the wide variety of personalities and stuff like that. You don't really have to fit into like an exact mold, and a lot of people think, big company, everyone needs to sort of fit in that mold. But at our research center, it's not quite like that. I mean, we even hire in, like in my Greenbelt class last week, I had 3 people in there who had been university professors. And now they've joined the research center. They're having a great time. They're loving it. And here they are in Greenbelt class. And just the stories, it was just great. Okay, that was the second question. Now, the first question, the answer to that is it depends. Now, in some cases, a business unit, if they really have a sense of the technology in place that they need for that product, they're just going to go do that. Okay, they don't need to involve us in that. Where we would get involved is if there's some sort of underlying technology that needs to be developed, is missing, they're not quite sure how to make it work, and that kind of stuff, then absolutely, that's what the business program managers are there for, is to really sort of scope out what are those things going on, where we might be needed. And of course, honestly, over time, our researchers build up tight relationships with people at the business, even directly. And they'll have that discussion. But then there will be the discussion, about feasibility. Okay, and at that point, pull in the marketing folks. Okay, what are you doing from that side? What do we think the opportunity might look like? So yeah, all those discussions are going to happen. And in some cases, it goes through that business program manager, but a lot of times it happens on, a direct personal contact sort of level. But what we are supposed to be doing as a research center is developing technology for longer range sorts of things. Now, I mean, that could be just a few years, it could be 10 years. But if it's something that the business already knows how to do, then they're just going to go do it. Make sense? Okay.
I'll go. I thought there was somebody else. Sorry. So thank you very much for your presentation and this information. You mentioned that most of this training and participation is voluntary, and that also that people are required to get Greenbelt certification in a lot of areas. So one of the dangers of requiring somebody to get Greenbelt certification is that they take the class, take the test, complete a project, and say, "Whoo, I'm glad that's over," and you never hear from them again. So what do you do to keep people recycling and doing more projects at the Greenbelt level?
Yeah, so actually it's very interesting you say that. I'll be honest, I mean, you know, I joined the company, we had already started the Six Sigma thing. If I was doing it now, I probably would not do it that way. That's why when we started doing the trees related stuff, I actually had a senior manager say, okay, so are we gonna require everybody to go to a trees workshop? And I said, no, we're not. Now it's interesting, over time, almost everybody has been, okay? But I said, no, I'm not gonna require it because my concern was people will be like, yeah, whatever. And then, you know, treat it like a box to check off. Now I will say, at the Greenbelt level, we do require it. And honestly, I mean, we require it because, I mean, I need my scientists to understand how to do a gauge R&R, okay? If they haven't seen like DOE before and they're doing stuff in a lab and an experiment's $10,000, I need them to know about that. So yeah. So we do that. Now, what we try to do, though, is in the class, I mean, it's very hands-on, lots of case studies. We actually have them go in and present, like, what they're working on and then help them scope out, like, what a project might be and stuff like that. And then they work directly with a mentor and stuff like this. So many of them, after just a couple years, are the ones that say, you know, I really would like to do the Black Belt program, which requires 1-over-1 approval to go through that. But like in the Black Belt class I just had, I mean, a lot of those folks that were in there were like, yeah, I mean, there were some that were like, say, 10 years with the company, but a lot of them were less than 5 and just really got fired up about it. So we also try to identify, you know, people like that as well. But I definitely understand where you're coming from, and we see it. And there's always going to be some people like that, but we try to really tie it to, okay, this is going to help you because, I mean, the fact of the matter is a lot of our people that come in, they've just come out of school. I mean, the thing that happened last week with the 3 professors, that's unusual. Okay, most of them are right out of school. So they were in a university research program. I mean, most of them have PhDs. And you know what? Yeah, they may have had a target graduation date, but as long as they still had funding and stuff, a lot of them graduated later than they probably planned. They have 1 professor they're working for and 1 project. Now they show up to us. They might be working on 2 or 3 projects, so that's 2 or 3 different project leaders with different expectations and things like that. And then, oh my gosh, they have deadlines. So the thing is, what I tell them is, you know what, we hired you, mechanical engineer, we hired you, computer scientist, we hired you because you are extremely good at what you do, and that's what we need you doing here. But we have deadlines, we have, you know, risks that you may not be used to taking and all this kind of stuff, and these tools will help you deliver in that kind of environment. And most of them get that. Because by the time they show up to Greenbelt class, they've already been around a couple months and they've already seen it. Okay. All right. Right on time.
Martha, we enjoyed your presentation and we thank you for it. I want to present you with your award
Oh, thank you very much.
and your certificate.
Oh, excellent. Thanks, guys.